Welcome to the Deep Dive, the place where we cut through the noise and get straight to the technical heart of what matters in AI and ML development.
Glad to be here.
Today, we are analyzing what is being called a fundamental shift in large language model capabilities. This feels like a significant movement in the frontier of the state of the art.
It really does. Look, when Google releases a new model generation, the claims are always high, but with Gemini 3 Pro, the technical metrics genuinely seem to support the hype.
Okay.
We are looking at a system that demonstrates really unprecedented reasoning capacity, true native multimodality, and it seems to be specifically architected for autonomy.
That sets our mission today, then. A dedicated technical exploration of Gemini 3 Pro. We're going deep into the hard performance metrics, the architectural specs that enable those feats, and critically, the new developer tools it unlocks.
Right, things like Generative UI and the Google Antigravity platform.
Exactly. Our focus is squarely on the how and what this means for you, the developer or researcher, who needs to start building with this power, immediately.
And we really need to anchor this discussion in verifiable data. Gemini 3 Pro is being advertised as Google's most intelligent model yet.
Right.
It's not enough to just say it's smarter than 2.5 Pro. We need to dissect exactly which metrics demonstrate this improved intelligence and why they signal progress toward more generalized reasoning.
Let's jump right into section 1 then and unpack those metrics. The model has topped the El Marino leaderboard, which is a great headline, but that's a measure of raw competitive strength. What are the scores that really demonstrate a cognitive breakthrough?
Well, we've seen it top the El Marino leaderboard with a breakthrough score of 1501 ELO, which is certainly impressive. You can't ignore that.
Sure.
However, the scores that signal a qualitative change are those demanding genuine synthesis and deep doctoral level comprehension. For instance, look at the high-stakes reasoning benchmarks.
Okay.
It hit 37.5% on humanity's last exam without tools, and a staggering 91.9% on GPQA Diamond.
Okay, we have to pause there for a quick technical definition.
Right.
For those who might be unfamiliar, what does performance on GPQA Diamond actually signify? What is it testing?
So GPQA Diamond is a benchmark composed of very difficult, expert-level, multiple-choice questions curated by PhD-level researchers.
Got it.
So achieving 91.9% here means the model isn't just recalling information. It is solving problems that require understanding complex, contradictory, and nuanced subject matter, the kind of synthesis previously only reachable by specialized humans.
And what about the traditional, painful frontier challenge of advanced mathematics? How does it fare there?
That's another key area. Math Arena Apex is notoriously difficult, and it's testing the model's ability to apply complex mathematical theory, not just arithmetic.
Right.
Gemini 3 Pro set a new best score there at 23.4%. And this combination high-level reasoning plus complex math is essential for truly complex code generation.
Now let's overlay that with the native multimodal capabilities. It isn't just handling text and images anymore. It's tackling video and audio from the ground up.
Correct. The multimodal reasoning scores hit 81% on MMMU Pro, which is the advanced measure for mixed modality tasks.
And for video?
It gets 87.6% on video MMEU, meaning it can analyze and synthesize information extracted directly from video streams. Finally, they report serious progress on reliability and factual accuracy, scoring 72.1% on Simple QA verified.
Which suggests a stronger internal consistency.
Exactly, and that's absolutely crucial for agent reliability.
Okay, let's run a neural signal check here. For a developer focused on building, say, a complex simulation or data analysis tools, what does this convergence of high scores, PhD reasoning, complex math, and native multimodality, what does it actually mean at the fundamental technical level? Give us the so what.
Right. The so what is that this convergence indicates a qualitative shift in the model's capacity for complex concept synthesis. Previously, a model might score well on one domain, but then fail when asked to bridge two. Now, when a researcher tasks the model with, say, generating the high-fidelity simulation code and visualization for plasma flow dynamics in a Fusion tokamak, the model has to simultaneously demonstrate a few things.
A few key abilities.
Yeah. One, the advanced mathematical understanding, that's your Math Arena Apex score. Two, the core physics reasoning, that's GPQA Diamond. And three, the ability to output visual code, which is a multimodal task.
So it's the technical integration of those separate cognitive functions that is the breakthrough here.
Precisely.
It proves that the model can grasp the conceptual depth of a problem and translate that into actionable cross-domain outputs rather than just generating statistically probable text.
Yes, it can access and utilize multiple advanced domains simultaneously, which suggests a far more robust, dense internal knowledge structure.
That power, of course, relies on the underlying technical specs. So let's transition into section 2 and talk about architecture, focusing particularly on capacity and context.
Absolutely.
Yeah.
Foundational architecture supports native multimodality. So inputs can include text, images, audio, and full video files.
Mhm.
The text output capacity is specified at 64,000 tokens.
And big one, the context window.
The context window officially supports up to 1 million tokens, which, if reliable, is massive.
Reliability really is the key word, isn't it? Because we've heard chatter in the developer community, people using the Vertex API, suggesting that the infrastructure might actually support a full 2 million tokens in some environments.
Right.
That's tantalizing, but as a technical professional, is chasing that 2M ceiling a wise move?
It's a classic frontier developer temptation.
Yeah.
While the potential for 2M tokens suggests that the underlying architecture has that capacity, we have to proceed with caution.
Because it's not documented.
It's not. The official 1M limit is the documented tested maximum. Using an undocumented endpoint, even if it seems to work, introduces significant reliability risk for mission-critical applications.
Good point.
More importantly, the benchmarks indicate improved retention compared to the 2.5 Pro, which saw noticeable degradation past the 100,000 token mark.
Oh, okay.
A true, reliable 1M context without degradation is a far bigger, more crucial quality of life improvement than chasing an unstable 2M.
A reliable million tokens means you can truly load full technical manuals, entire code bases, or multiple legal documents without fear of the model, forgetting the beginning.
Correct. Eliminating that lost-in-the-middle problem that plagued earlier generations. This reliability improvement is likely a more complex architectural fix than simply widening the bottleneck.
Okay, shifting gears slightly on the architecture. We have to address the knowledge cutoff date. It's consistently January 2025, the same as 2.5 Pro.
Yeah.
What does this technical consistency imply about the economics of training these frontier models?
I think it points directly to the increasing length and, frankly, the immense capital cost of training these models. Retraining models of this scale, especially those incorporating native multimodality, frequently with fresh data, is becoming increasingly prohibitive.
So we're seeing a technical slowdown in the knowledge base refresh rate.
That's what it looks like.
So how does Google mitigate the fact that the core trained knowledge is static since early 2025?
They emphasize their reliance on search grounding features. The model's reasoning capability, which is derived from that expensive deep training, remains powerful, and its capacity to understand the world is fixed.
But it needs current information.
Exactly. So the up-to-date facts come from external search results integrated during inference. The model reasons deeply, but it uses current context, provided by a separate tool to fill in the recent gaps. It's an effective technical hybrid.
Now let's talk about pure performance optimization. The high-performance sibling, Gemini 3 Deep Think Mode.
Deep Think mode is essentially an enhanced reasoning pipeline. It likely involves additional compute or maybe multi-pass processing internally.
And it pushes the metrics even higher.
It pushes those high-stakes metrics even further, 41.0% on Humanity's last exam, 93.8% on GPQA Diamond.
But the metric that truly captures the imagination of agent researchers is its score on ARC-AGI-2, specifically with code execution. Hitting 45.1% there is?
Well, it's unprecedented.
It is. And we should clarify that RCAGI2 stands for Abstract Reasoning Corpus. It's a measure of fluid intelligence.
So it's different from GPQA.
Very different. Unlike GPQA, which tests specialized knowledge and recall, ARC-AGI2 presents novel, visual, analogy-based puzzles designed to measure generalizable problem-solving ability. The model has to infer the underlying rules of a system it has never seen before.
So if the model can successfully infer and solve novel challenges, demonstrating fluid intelligence, that ability translates directly into what?
It translates into generalized autonomy. It means the model doesn't just execute predefined plans, it can generate a novel, reliable plan for a task it hasn't encountered in its training data. This is the bedrock for the next generation of agents.
Yeah. And that achievement raises an important technical question for you, the listener. If a model demonstrates this level of problem solving, how does that fundamentally change the design constraints for autonomous systems?
That leads us perfectly into Section 3. agentic coding, and the new developer ecosystem. This model is explicitly designed not just to answer questions, but to take complex action.
Absolutely. It is defined as the best model yet for what Google calls vibe coding and agentic coding.
Okay, let's clarify that jargon.
Vibe coding refers to rapid, intuitive prototyping generating complex components or applications from vague natural language instructions. Agentic coding is using the model to autonomously handle the full software development lifecycle.
And how does the performance back up that claim?
We'll look at the performance benchmarks for functional utility. It tops the WebDev Arena leaderboard with 1487 ELO, meaning it is demonstrably better at generating functional, complex web components.
And its ability to interact with an environment.
That's the crucial part. It's strong. 54.2% on Terminal Bench 2.0, which tests its ability to operate a computer via terminal interface, and a massive lead over 2.5 Pro on SW Bench Verified, hitting 76.2% on verified software engineering tasks.
Those agentic advancements are intrinsically linked to the new agentic development platform. Tell us about Google Antigravity.
Google Antigravity is a platform designed to give the AI agent autonomous access to the core development environment. The technical leap is this. Anti-gravity agents are granted direct, secure API access not just to a static prompt box,
But to the actual tool.
to the editor, the terminal, and the browser.
So the agent is executing full end-to-end tasks simultaneously. It's not just generating code and handing it off for a human to test.
Precisely. Using Gemini 3's deep reasoning, the anti-gravity agent can autonomously plan a task, write the necessary code in the editor, compile and run the code via the terminal, and then validate the result by interacting with the output in the browser.
All as part of one unified agentic workflow.
Yes. And this often involves specialized tools. For example, the Nano Banana model, which is an internal utility they mentioned, optimized for localized high-speed image editing tasks.
That demonstrates a true agentic workflow. Let's look at the other major capability tied to Gemini 3, generative UI, or dynamically generated interfaces.
This is a powerful new paradigm, moving beyond simple static outputs. The model generates not just text or images, but the entire user experience, interactive tools, simulations, web interfaces, all dynamically based on the user's intent and context.
What kind of technical stack is required to enable this generative UI? It must be more complex than just piping the LLM output directly into a browser.
It absolutely requires a specific technical setup layered on top of Gemini 3 Pro. You need three key components beyond the base model.
Okay, what are they?
First, robust tool access via a server, allowing the model access to things like image generation APIs, web search, and data plotting libraries. Second, carefully crafted system instructions.
And these aren't just simple prompts.
No, these are detailed guidance on goal setting, multi-step planning, output formatting, and even error avoidance.
And what's the third component?
The third is post-processing, a rapid, low-latency step to quickly check and correct common formatting errors or structural issues in the generated UI code before it's presented to the user. This ensures a reliable experience.
So the technical outcome is that the model can customize the interface with nuance.
Yes, like dynamically generating an interactive 3D model explanation of a biological concept tailored specifically for a high school student, leveraging its improved reasoning and spatial understanding.
That level of dynamic interface creation, customized to user intent, is where we see the fusion of reasoning and output utility.
It really is the next frontier of human-computer interaction.
Let's dedicate Section 4 to the practicalities, deployment and developer economics. Gemini 3 Pro is available now, but we noted Deep Think mode is still forthcoming pending those final safety evaluations.
Correct. Pro is ready today in AI Studio and Vertex AI. And developers immediately need to understand the cost implications, as this is a demonstrably more expensive model to run than its predecessor.
Let's compare the paid tiers for standard usage, say prompts under 200,000 tokens for 3 Pro versus 2.5 Pro per 1 million tokens.
The input cost for Gemini 3 Pro is $2 per 1M tokens. This is a 60% increase over 2.5 Pro's input cost of $125.
And on the output side,
Similarly, output costs show an increase. Gemini 3 Pro is $12 per 1M tokens compared to $10 for 2.5 Pro.
so the immediate technical implication is that highly complex reasoning and multimodal integration demand higher compute and therefore higher inference costs.
Right.
This means developers must be extremely deliberate about how they structure their API calls.
Absolutely. The decision to use 3 Pro should be based on necessity. If you need 93.8% DPQA diamond performance, you pay for it. However, Google does offer specific technical mitigations to offset these costs for specific workflows.
Let's focus on those mitigations, starting with the Batch API.
The Batch API offers a substantial 50% cost reduction on both input and output traces. This is crucial for developers running large-scale asynchronous tasks, like processing 1 million documents overnight,
Yeah.
where immediate latency is not critical.
It lets Google optimize on their end.
It allows them to optimize resource utilization dramatically, yes.
And the other major feature for cost and latency management, context caching.
Context caching is vital for any application that relies on repeatedly sending the same massive system prompt or a large foundational document to the model.
I see.
Instead of repeatedly transferring and reprocessing that expensive input context across a network, you cache it.
So what's the pricing structure for that technical benefit?
It's available for both paid tiers and is priced based on the size of the cached prompt, plus an hourly storage fee of $4.50 per 1 million tokens per hour.
And the technical payoff is twofold.
Exactly. Dramatically reduced latency, as the model doesn't have to reread the context, and cost savings on input tokens for every subsequent call that utilizes the cache. It shifts the cost model from per-call input fees to a low-cost hourly context maintenance fee.
This has been a deep technical review of the Gemini 3 Pro ecosystem. I mean, the leap in reasoning, as proven by those ARC, AGI2, and PhD level benchmarks, is absolutely quantifiable.
It is. And that reasoning power is immediately being channeled into systems for autonomy. The focus has undeniably shifted from pure response generation to comprehensive agentic action and dynamic interface creation.
Exemplified by Google Antigravity and Generative UI.
Right.
The model is designed to be an active, fluid intelligence that can operate entire systems and build custom interfaces on the fly. We've seen the impressive results, particularly on tests of fluid intelligence like ARC AGI2.
Which leaves us with a final thought for you to mull over. If highly capable models like Gemini 3 Deepthink are demonstrating this unprecedented success on tests of fluid intelligence, what does the technical roadmap look like for the next generation of agentic development platforms?
Where do we go from here?
We're currently focused on text and code generation. What happens when the technology reliably moves to generalized computer operation via the emerging screen spot paradigm, where the model perceives the desktop and operates the computer visually? What new infrastructure will be required to handle that complexity?
Something to keep in your context window. That's all the time we have for this deep dive. Thank you for joining us.